Hi, hello dear students. Welcome to our channel Maths with Panindra. In this video, we are going to discuss about in probability very important concept Bayes theorem. What is the importance of Bayes theorem and whose applications we are going to discuss exclusively in this video. Not only proving the theorem but also examples regarding this we are going to discuss now. Let us have a discussion the Bayes theorem statement and proof. Bayes theorem. If A1, A2, A3 and so on AK and so on AN are mutually exclusive and exhaustive events in a sample space S such that probability of AI is greater than 0 for I equal to 1, 2, 3 and so on and E is any event in the sample space S and P of E is greater than 0, then probability of kth event of A, when we know the probability of E, the meaning of P of AK given E, that means the probability of each event when we know to calculate the kth event of A. So probability of AK given E equal to P of AK into P of E given AK by sigma I is equal to 1 to n P of AI into P of E given AI for k equal to 1, 2, 3 and so on n. So first in the proof, foremost thing, the given information in the statement. Sometimes in the question, state and prove Bayes theorem, like this also they will ask. So you have to remember the statement of the Bayes theorem. So first whatever the information is there, that you have to write it clearly, dear students. Let A1, A2, A3 and so on AK and so on AN are mutually exclusive and exhaustive events in a sample space yes, in a sample space yes. This is the first step. I hope you understand that these are the events we are considering in the sample space. What is mutually exclusive, exhaustive? I already discussed in the previous videos. Please go through the playlist, dear students. Those who are watching first time this channel, please do subscribe and go to the previous videos and get into the information. Now, after assuming this, we have to assume one more event in the sample space. Just I will draw a rough figure for understanding purpose. This is the sample space. Yes, it contains the events A1, A2, A3 and so on AK and so on AN. These are the events are there in this sample space. Yes, here let E be any event. Let E be any event. Let E be any event in a sample space. Yes, and the union of these exclusive exhaustive events is equal to yes, their only definition. Exclusive events, exhaustive events, the definition represents the union of these, that is A1 union A2 union A3 union and so on AK and so on union AN is equal to sample space. The union of these events, and E is also any other event in the sample space S. Instead of writing all A1 union A2 union A3 and so on, we can write it as union of I is equal to 1 to n, AI is equal to S. This you have to put it in box. That is union I is equal to 1 to n, AI is equal to S. Not only this information, but also disjoint events are there. If you observe this figure, E and A1 are joined. E and A1. E is any event. There is no link, there is no common thing from this. So these are the disjoint events. E and A1 is disjoint. E and A2 disjoint, E and A3 disjoint, and so on. E and AK disjoint, and E and AN also disjoint. That information we need to write it. Disjoint means their intersection is equal to 5. E intersection A1, E intersection A2, E intersection A3, and so on. E intersection AK, and so on, E intersection AN or disjoint events. Disjoint events. I hope you understand it, students. First, we assume that events which are exclusive, exhaustive events. This step is very important. You need to mention that. Mutually exclusive and exhaustive events in the sample space S. After that, let E be any event in the sample space S with the probability. Anyway, any probability is always greater than 0. Even here also all are. And P of AI is greater than 0, where I is equal to 1, 2, 3 and so on n. All are. Probability means it is always greater than 0 and less than 1. Even here also E is greater than 0. From this figure, if you observe that E and S, if we consider E and S, E is the small thing, S is the big thing. So common is E only, So the product we are considering here, E is equal to, consider E is equal to E intersection S. Can we write like this from the set theory? E can be written as E intersection S. Taking probability on both sides, P of E is equal to P of E intersection S. What is S value? S we have over here, which is equal to P of E intersection. In place of S, union I is equal to 1 to n AI. We can write it. This union, if you interchange, which is equal to in the probability function, P of union I is equal to 1 to n E intersection AI. If you are taking out from the probability function, this union will become summation or sigma, which is equal to one of the properties of probability distributions as well as set theory. So sigma I is equal to 1 to n, sigma I is equal to 1 to n, P of E intersection AI. By definition of condition probability, sigma I is equal to 1 to n, P of E intersection AI can be written as P of AI into P of E given AI. So this is about the probability of the event P of E. This result will help in the coming steps. Keep in mind. Of course, do you know about this one? This is total probability theorem which we discussed in the earlier classes. P of E value. It will help in the coming steps. Next, within 4 steps, we are going to finish the Bayes theorem. What is the aim of Bayes theorem? That after completing of P of E step, among these events, P of E, the probability of this particular event, we got it. When we know the probability of the particular event E, we need to calculate the kth event of A probability. For that, we need to apply Bayes theorem. Among these events, E event probability, we got it here. When we know the probability of E, to calculate either first or second or third or kth or nth event of A, when we know the probability of E, we need to apply Bayes theorem. That also basic, this completely Bayes theorem based on condition probability. Even condition probability also we discussed in the earlier classes, dear students. See here, the probability of kth event, probability of kth event, when we know the probability of E, when we know the probability of E is, from condition probability definition, probability of A, when we know the probability of B means P of A by B, we will write it. Similarly, the probability of AK, when we know the probability of E, can be written as P of AK given E, which is equal to, again by definition of condition probability, we can write it as P of AK intersection E divided by P of E. What is P of E we have here? Which is equal to P of AK intersection E divided by P of E can be written as summation I is equal to 1 to n P of AI into P of E given AI. This is P of AK given E. Again, by using condition probability, P of AK intersection E can be written as P of AK into P of E given AK. K is the suffix my here, dear students, by sigma I is equal to 1 to n P of AI into P of E given AI. This is about the Bayes theorem. P of AK given E is equal to, where K equal to 1, 2, 3 and so on n. This is about to prove the theorem. I hope you people understand. I will give the examples regarding this, dear students. Yeah. Next example for this Bayes theorem. Bayes theorem statement I already kept here. How we are going to apply for showing this information, I kept like this only. So first question is, 3 boxes numbered 1, 2, 3 contain the balls as follows. The table is given. So first box, white, black, red. 1 white ball, 2 black balls, 3 red balls. Second box, 2 white balls, 1 black ball, 1 red ball. In the third box, 4 white balls, 5 black balls, 3 red balls. So total how many balls are there in the respective box? The first box, total how many are there? 6 balls are there, total balls. In the second box, 2 plus 1 plus 1, 4 are there. In the third box, 4 plus 5 plus 3. So how many it is? 9 plus 3, 12 are there. I hope you understand now. In the first box, like this way. After that, one box is randomly selected. Out of these three, one box is selecting. And a ball is drawn from it. Whatever the box we are selecting, from that the ball is selecting. If the ball is red, then find the probability that it is from the box 2. So first we need to find the probability of the respective boxes. What are the boxes are there? The boxes, the number of boxes. The number of boxes. 3. What is that name? Box 1, that means B1, B2, like B3. Otherwise you can give the number also 1, 2, 3. That is also can. Total 3 boxes are there. One box I want to select. Out of 3, one we can select in 1 by 3 ways. So total number of possibilities is 3. One box I want to select, so 1 by 3. So the probabilities of respective boxes, P of B1. Out of these 3, one box, first box will be selected as 1 by 3. Even second box also you can take out of 3, 1 by 3 only. So P of B1, P of B2 and P of B3 all are equal. I hope you understand it, students. The probability of selecting the boxes. This is the probability of selecting boxes. So selecting the box is completed. Now you have to assume one event. Let E be the event that selecting, let E be the event that selecting a ball is right. E be the event of selecting a ball is red. Here only red. Ball is red. So red ball, not only one bag, no, 3 bags are there. So selecting the red ball from which bag? First bag we will see that. The probability of E by B1. The meaning I will explain here, dear students. Observe carefully. Let E be the event of selecting a ball is red. Now, the probability of event E selecting red ball from where? From B1. In B1, total how many balls are there? 1 plus 2 plus 3, total 6 balls are there. Out of 6, 1 ball you can select. It will be done in 61 ways. How many red balls are there particularly? 3 red balls are there. From that one we can select. So 3C1, which is equal to 3C1 is 3 by 6, which is equal to 1 by 2. Therefore, the probability of E given B1 is 1 by 2. Similarly, the probability of E by B2, E by B3 also we will calculate. P of E by B2. That means the probability of selecting a red ball from the box 2. So in box 2, how many balls are there? Total 4 balls are there. From that we can select 1 ball, 4C1 ways. How many red balls are there? Only 1 red ball is there. We can select as 1C1 ways. That is equal to 1 by 4. Similarly, the probability of selecting a red ball from box 3, which is equal to total how many balls are there in the third box? 12 balls are there. Out of 12, I can select 1 ball in 12C1 ways. How many red balls are there here? 3 red balls are there. We can select 1 ball, that is in 3C1 ways. So 3C1 means 3 divided by 12C1 is 12. So 3 ones are 3 fours are 1 by 4. We got it respective balls and bags. Respective ball is only red with respect to different bags. Till here I hope you understand, dear students. We will move on to the next step. This is the turning step and the required step. The probability of selecting a red ball which is drawn from the box 2. We know that from where we are selecting. The probability of the probability of selecting a red ball from box 2. So the probability of selecting the box 2, and we are drawing which ball? Red ball. Red ball event is E. So from particularly box 2 they are selecting. So P of B2 by E we want. The probability of B2 by E. Here we are calculating E by B1, E by B2, E by B3. But we want the probability of selecting second box. From that red ball probability we are calculating by using this Bayes theorem here only. By using Bayes theorem, so based on this, P of box 2 into P of E given box 2 by this application of that doing. P of kth event, particular event of the total 3 events are there. From particular event we are calculating. E probability we know that. P of B2 into P of E by B2 into P of E. So what is P of E, sir? P of E is, which is equal to P of B2 into P of E by B2 by sigma I is equal to total how many boxes are there? 3 boxes are there. I is equal to 1 to 3 P of Bi into P of E by Bi. Means I is equal to 1, 2, 3, substitute like capital 1, capital 2, capital 3 only write it. You will get the answer, dear students. Which is equal to P of B2. P of B2 value is what? 1 by 3 into P of E by B2. P of E by B2 here we have 1 by 4 by, here I is equal to 1, substitute P of B1. Yeah, before substituting only, first we will finish it all whatever it is there. P of B2 only directly write it. P of B2, P of E given B2, all at a time we will do it. Next I is equal to 1, substitute P of B1 into P of E by B1 plus, sigma means plus, P of I is equal to 2. So P of B2 into P of E by B2 plus P of B3 into P of E by B3. So now substitute the respective values. 1 by 3 into 1 by 4 P of E by B2 value whole divided by P of B1 value is 1 by 3 into P of E by B1 1 by 2 plus 1 by 3 into P of E by B2 1 by 4 plus 1 by 3 into P of that is also 1 by 4, which is equal to 1 by 3 into 1 by 4. In the denominator all 1 by 3 take common and the rest of the term is 1 by 2 plus 1 by 4 plus 1 by 4. First 1 by 3 cancel. 1 by 4 divided by 1 by 2 plus 1 by 4 plus 1 by 4. 1 by 4 plus 1 by 4 is 1 by 2. 1 by 2 plus 1 by 2 is 1. So 1 by 4 is ultimately. Therefore, the required probability is equal to 1 by 4. I hope you people understand. We'll move on to the next questions. Next question number 2. This is second example for the Bayes theorem. One urn is randomly selected and a ball is drawn from it and it turns to be white. Find the probability that it is from urn 3. So total here 3 urns numbered as 1, 2, 3 contain the balls as follows. But here in each are white and black balls also available. There is no red balls here. The question is, find the probability that it is from urn 3 that ball should be a white. Here it is mentioned clearly. The white ball selection from the urn 3. So total how many urns are there here? 3 urns are there. So the number of urns, 3. So not B1, previously we wrote, this is U1, U2, U3. Urn 1, urn 2, urn 3. So out of 3, 1 urn selecting in 1 by 3 ways. So each and every urn, P of U1, P of U2, P of U3, according to our convenience and writing. Selection of the probability of selecting the urn is 1 by 3. Let E be the event that selecting a ball is white. This is also very important. E be the event of selecting a ball is white. Next, the probability of selecting a ball is white from the back 1. That means from the urn 1, U1. So in U1, total how many balls are there here? 1 plus 2, 3 balls are there. So out of 3 we can select 1 ball. How many white balls are there particularly? Only 1 white ball is there. So 1 white ball select in 1 base, 1 C1 base, which is equal to 1 by 3. Similarly, the probability of E given E2, the probability of selecting a ball is white, which is from urn 2. So urn 2. Total how many balls are there? Here also 3 balls are there. But how many white balls are there? 2 white balls are there. From the 2 white balls we can select 1. From the 3 total 1. So 2 by 3. Come to the third one, P of E given U3. The probability of selecting a ball is white from the urn 3. So total here 4 balls are available. In that 2 white balls are there. So from total 4 balls we can select 1 in 4 C1 ways. And 2 white balls are there, we can select 1 2 C1 ways. So 2 by 4, which is equal to 1 by 2. The next required probability, the probability of selecting a white ball from urn 3, U3. By using Bayes theorem, P of U3 divided by E, that means U3 given E is equal to P of U3 into P of E by U3 by P of E. That means P of U3 into P of E by U3. So I is equal to 1 to total 3 events are there, 3 urns are there. So P of UI into P of E given UI. I is equal to 1 2 3, substitute P of U3 into P of E by U3 divided by P of EU1 into P of E by U1 plus P of U2 into P of E by U2 plus P of U3 into P of E by U3. So the respective values substitute here. P of U3, it is 1 by 3 into P of E by U3, 1 by 2 whole divided by 1 by 3 into P of E by U1, 1 by 3 plus 1 by 3 into P of E by E2, 2 by 3 plus 1 by 3 into P of E by U3, that means 1 by 2. So which is equal to 1 by 3 into 1 by 2 by 1 by 3 take common from the denominator. So the rest of the terms is 1 by 3 plus 1, 2 by 3 plus 1 by 2. So here 1 by 3, here 1 by 3 get cancelled, which is equal to 1 by 2 by 1 by 3 plus 2 by 3 is 4 by 3, 4 by 3 plus 1 by 2. So 1 by 2 divided by LCM is 6, 3 2s are 2 into 4, 8 plus 2 3s are, which is equal to 1 by 2 into 6 divided by 8 plus 3, 11. Sorry, 1 by 3 plus 2 by 3 is 3 by 3. Very sorry. So it is 1 only. So 3 2s are 3 to 6. So 9. 2 1s are 2 3s are 3 1s are 3 3s are. So 1 by 9. Therefore, the required probability P of earn 3 by E is equal to the probability of selecting a red ball from earn 3. Conclusion step, the probability of selecting a white ball from earn 3 is P of E3 given E equal to P of 1 by 3. I hope you people understand. We'll move on to the another question. The next question number 3. 3 boxes B1, B2, B3 contain the balls given below. White, black, red balls are there in box 1, box 2, box 3. In the box 1, total 2 plus 1 plus 2, 5 balls are there. In the box 2, 9 balls are there. Even in the box 3 also, 9 balls are there. For selecting the boxes, here condition is there. A die is thrown. If a die is thrown, we have 6 possibilities. 1 or 2 or 3 or 4 or 5 or 6. Total 6 possibilities are there. B1 is chosen either 1 or 2 turns up. To select the bag 1, the probability of selecting bag 1 or box 1, either the numbers 1 or 2 it turns up. That means out of 6 these 2 numbers will be there. That means 2 by 6. Here you have to write it. The probability of selecting the boxes. So first box, P of B1 is equal to. So to select the first box, either 1 or 2 turns up, no? Selecting the boxes with a die is thrown with the conditions. But die is thrown is enough. To select the bag 1, box 1, either it turns up 1 or 2. So total 2 numbers are there out of 6. It will be 1 by 3. To select the box 2, P of B2, the die it turns up either 3 numbers or 4 numbers. Total 2 numbers are there, 2 by 6, which is also 1 by 3. Next, probability of selecting the third box. To select the third box, either 5 or 6. So 2 numbers are there, 2 by 6, which is equal to 1 by 3. So the selection process of boxes is over. After that, let E be the event that selecting the ball is red color dimension is red color. So red color balls not only in box 1, box 2, box 3 also we have. So from each and every box, the selecting of red balls we will see that particularly. So the probability of selecting a red ball, that means the probability of selecting red ball, E is the event that selecting a ball is red. From box 1. So in box 1, total how many balls are there? 5 balls are there. 1 ball we can select in 5C1 ways. How many red balls are there in this? 2 red balls are there. From that we can select 1, 2C1 ways. So 2 by 5. So P of E by B1 value is 2 by 5. Similarly, the probability of selecting a red ball from box 2, which is equal to the probability of selecting a red ball from box 2. In box 2 total how many balls are there? 9 balls are there. So out of 9 we can select one ball in 9 C1 ways. And how many red balls are there particularly here? 4 are there. 4 C1, which is equal to 4 by 9. The probability of selecting a red ball from box 3, which is equal to, in total box 3 also 9 balls are there, 9 C1. In that 2 red balls are there, we can select in 2 C1 ways. So which is equal to 2 by 9. So selecting the box is over. Selecting the red ball from the box is also over. But come to the, what is the probability that it comes from the box 2? That means the probability of selecting the box 2, when we know the probability of red ball, that means the probability of drawing a ball from box 3 or box 2, from box 2, a ball from box 2, and it is red, so selecting box is B2, P of B2, from where red ball means red ball probability is E here. So P of B2 given E, by definition of condition probability, we can write it as P of B2 into, by using Bayes theorem, not only condition probability, Bayes theorem. By using Bayes theorem, P of B2 into P of E given B2 divided by P of E. P of E means the sum of the probabilities. P of E, that is equal to P of B2 into P of E given B2 by P of E means P of B1 into P of E by B1 plus P of B2 into P of E given B2 plus P of B3 into P of E given B3. So total 3 are there. This information we are calculating now, which is equal to P of B2 by E. P of B2, what is P of B2 here? 1 by 3 into P of E by B2. E by B2 is 4 by 9 whole divided by 1 by 3 into 2 by 5 plus 1 by 3 into 4 by 9 plus 1 by 3 into 2 by 9, which is equal to 1 by 3 into 4 by 9 whole divided by 1 by 3 take common, 2 by 5 plus 4 by 9 plus 2 by 9. So 1 by 3 get cancelled, 4 by 9 by, here LCM is 45, 5 9s are 9 into 2 18 plus 9 5s are 5 into 4 20 plus 9 5s are 5 into 10, which is equal to 4 by 9 into 45 divided by 30 plus 18, 48. So 9 1s are 9 5s are 4 1s are 4 12s are, which is equal to 5 by 12. Therefore the required probability the required probability is P of B2 given E. That means the probability of selecting a red ball from box 2 is 5 by 12. Thank you dear students for watching our channel. If you have any doubts regarding this, please write to my comment box. I will help you. Thank you all. Happy Sri Ramanavami to all. Thank you all. Signing off. Maths with Panindra. Jai Hind.